This is 2.4 Equations of Lines, Part 2. So in Part 1, we looked at using point-slope form of a line, and in this section we're using the slope y-intercept form, which we're already more familiar with. Again, slope y-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. It's really helpful for drawing lines on the graph because it gives us some important information. We know that this is the y-intercept. The y-intercept occurs where our line crosses the y-axis. Well, that makes this point, you guessed it, the x-intercept. The x-intercept occurs where our line crosses the x-axis. Now, they cross these lines at a point. Now, the point at which the line crosses the y-axis is represented by xy, just like any other point, but the x value, you'll notice, is always going to be 0. So the y-intercept always occurs at the point 0, b. And that b comes right from our equation of the line. So for instance, if we had y equals 2x plus 3, then we would know that our y-intercept would be at the point 0, 3. Well, what about our x-intercept? If our y-intercept occurs where x is 0, then our x-intercept must occur where y is 0. We don't know what x is, but we can use the variable a to show that it's some number, any old number it could be, but we know for sure that the y-coordinate is going to be 0. Let's try a few problems applying our knowledge of slope y-intercept form. Example 1 of Part 2 says, find the slope and the y-intercept of the line 2x plus 3y minus 6 equals 0. What form have we been given our line in? That's standard form. And if we want to find the slope and the y-intercept, essentially all we're doing is converting this equation given in standard form into slope y-intercept form. Y equals mx plus b. So let's go ahead and rewrite the equation that we've been given. 2x plus 3y minus 6 equals 0. And our goal here is to rearrange into y equals mx plus b. And from there we can get our slope and our y-intercept quite easily. Well, let's start by getting our y term on the left and our term including the x and the constant on the right. So I'm going to subtract 2x from both sides, and I'm also going to add 6 to both sides. That will leave me on the left with just 3y, and that will be equal to negative 2x plus 6. Well, it's starting to look more like slope y-intercept form, but I notice I still have this ugly coefficient of 3 in front of the y term. So what I need to do is divide each of my terms by 3. If I divide this term by 3, I must divide this term by 3, and I must divide my constant by 3. Well, 3 over 3 is 1, so this just leaves me with y on the left. I'm okay with fractions. This is negative 2 over 3x plus 6 over 3, which is just 2. So the equation of the line in slope y-intercept form is y equals negative 2/3 x plus 2, where the slope, represented by m, equals negative 2/3, rise over run, so this is a negative slope, and the y-intercept is 2. That's all we needed to find, the slope and the y-intercept. We did so by first converting our equation into slope y-intercept form, and then just identifying m and b as our slope and our y-intercept. In example 2, we're still working with slope y-intercept form. In fact, same as example 1, I'm going to find the slope and the y-intercept. But this time I'm not given the equation in standard form. I'm just given 2 points that this line happens to go through. It goes through F and it goes through G. Well, I know that I have a formula that I can use for the equation of a line called point-slope formula, that I can find the equation of the line if I have a point and the slope. But I don't even have the slope here. But I do know that I can find the slope using these 2 points. So our first step is to find the slope of FG. Well, the slope of FG is the change in y over the change in x. That's really just our rise over our run from F to G. It doesn't matter which point I make x1 or x2 or y1, y2, but I'm going to start with G as x2, y2. So at the top here, I've got 7 minus negative 1 over 5 minus 3. That's 8 over 2, because 7 minus a negative is 7 plus 1, which reduces to 4. So the slope of our line is 4. I've already answered one part of the question, but in order to answer the second part, that is find the y-intercept, I'm going to need to use my slope, get this thing into an equation that gives the y-intercept, which is slope y-intercept form, and then I can get it straight from there. But in order to do that, I need to use point-slope formula. Point-slope formula looks like this. Y minus y1 is equal to the slope times x minus x1. Now it doesn't matter which point I use. I'm going to use f. Our line goes through f and g, so either one will work. I'm going to use f. So I have y minus negative 1, keeping track of my positives and negatives here, making sure I'm copying correctly. I know the slope is 4, and in the brackets I have x minus 3. The left side here reduces to y plus 1. I can distribute this 4 to the x and to the negative 3. That's 4x minus 12. Now I can subtract 1 from both sides. I get y equals 4x minus 13. There's slope y-intercept form. Here we have our slope. Here we have our y-intercept. So as a final answer, I'm going to say that the slope is 4 and the y-intercept is negative 13. Part 3 of lesson 2.4 deals with parallel and vertical lines. Now in class we already took, or in the previous video, we've already taken some notes on parallel and vertical lines, and so we know what their equations tend to look like as far as having the same slope or having a slope that's an opposite reciprocal. And we also have dealt with vertical and horizontal lines. The first example that we have here in part 3, I'll just write example 1 here for us, is to write the equation of the line that is parallel to 2x plus y minus 5 equals 0, and passing through the point A at negative 1, 5. Now the line that they've given us is in standard form. In order to decide if the line is parallel, I need to know what its slope is. Now this doesn't give me its slope. It gives me pretty close to its slope. You might say, oh, the y is already kind of by itself. It doesn't have a coefficient, so the slope must be 2. Wrong. You can't do that. Remember, we need to get this thing into slope y-intercept form first. So we're going to first convert to y equals mx plus b. And really all I need to do here is subtract 2x from both sides and add 5 to both sides. So on the left, I'm going to be left with just the y. Now I've subtracted 2x from both sides, and I've added 5 to both sides. So I'm left with y equals negative 2x plus 5. And here we have the slope of this line is negative 2. The line that I need is going to be parallel. Well, if a line is parallel to another line, they have the same slope. So if m1, if the slope of my first line is negative 2, then the slope of my second line must also be negative 2. Since the lines are parallel, we're told that the slope of the second line is also -2. Now what about this information that it goes through the point A at -1, 5? Well, I think I have a formula that I can use if I have a point and I have the slope. That's right, the point slope formula. And we'll record it again each time we use it to help us memorize it. It's y minus y1 is equal to the slope times x minus x1. Now I don't have to choose between points that I want to use. I'm only given one point, so I can just sub those values in. Y minus 5 is equal to the slope, which is -2, times x minus -1. Well, let's figure out what's in this bracket here. That's actually x plus 1. So we'll rewrite it again. We've got y minus 5 is equal to -2, x plus 1. Now we can use our distributive property to distribute that -2 to both of the terms inside the binomial. We've got y minus 5 is equal to -2x minus 2. And now I simply add 5 to both sides. Y is equal to -2x plus 3. So the equation of the line that goes through the point A and is parallel to our original line is y equals -2x plus 3. And we could write it in standard form as well. To write it in standard form, all we need to do is move all of our terms to the left and leave 0 on the right. So we're just going to do this again. We're going to add 2x to both sides and subtract 3 from both sides. We're going to be left with 2x plus y minus 3 equals 0. In example 2, we're faced with a problem that deals with perpendicular lines. We need to come up with the equation for the line that is perpendicular to 3x plus y minus 6 equals 0 and passes through the point P at 5, 2. So again, we're dealing with perpendicular lines. That means we need to be familiar with the slope of this line. I cannot derive the slope of the line directly from the standard form of this equation, so I'm going to convert it to slope y-intercept form, y equals mx plus b, by subtracting 3x from both sides and then adding 6 to both sides. It's going to leave us with y equals -3x plus 6. I'm going to call this line 1, and I'm going to call this slope 1. So slope of line 1 is -3. Now, if our new line is going to be perpendicular to our original line, then the slope has to be the opposite reciprocal. When we look at this, -3, you might think, well, that's difficult to make it a reciprocal. I can make it opposite. Instead of being negative, my new slope is going to be positive. But what's the reciprocal of 3? Well, remember, 3 is really just a fraction, 3 over 1. If I flip that, I get 1/3. So the opposite reciprocal of -3 is positive 1/3, which tells us that the slope of our perpendicular line is positive 1/3. Okay, now I have the slope, and I'm told that my new line passes through the point P at 5, 2. You know this formula well by now. It's slope point slope form, and it's y minus y1 is equal to the slope times x minus x1. And now I sub in the points that I know. Y minus 2 is equal to my new slope, which is 1/3, times x minus 5. Now I need to distribute 1/3 to both of my terms inside the brackets. We get y minus 2 on the left still, and I have is equal to 1/3 x minus 5/3. Now, it doesn't say what form I need to write the equation in. It just says I need an equation of the line that's perpendicular. Sometimes working with fractions is difficult, so what can I do to eliminate the fractions in this equation? I can use an equivalent equation and multiply all of the terms in this equation by 3. Then this equals will still be true, and I won't have changed a thing. It will represent the same line. It's an equivalent equation. So I'm going to multiply all the terms by 3. We're going to be left with 3y minus 6 is equal to x minus 5. Let's put this thing in standard form again by moving all of my terms one direction. I'm going to move all my terms to the right because I notice if I subtract x from both sides, I'm going to be left with negative x with negative 1 as its leading coefficient, and I don't want that. So I'm going to subtract 3y and add 6 to both sides, leaving me with nothing on the left side, 0 as a placeholder. And then I'm going to put these things in order right away. I'm going to have x minus 3y, and then I have plus 6 minus 5. Well, that's plus 1. And there we have our equation of the line in standard form that is perpendicular to the line we were given and passes through the point P 5, 2. The homework for this lesson is recorded at the bottom of your example handout. It was a short lesson. Go ahead and get started on that work.